The second possibility is a possibility that the results are due to chance factors, such as one group getting a few more tired people just by chance. And this possibility is confidently eliminated if the results are statistically significant. If you've taken a statistics class before, you might have learned about something called the significance test. In a significance test, a researcher takes a set of data that was gathered during a study, and the researcher plugs the data into a formula to get a value that tells the researcher if the result is statistically significant. And if the result is statistically significant, then the researcher can confidently say that the results of the study are not due to chance factors. When a researcher gets a statistically significant result, the researcher can confidently say that the results are due to something other than chance, but not with 100% certainty. The researcher is just highly confident that the results are due to something other than chance. And in this video, I'm not going to go into all of the details of how a significance test is done, because that's not the purpose of this video. In this video, I just want to give you an overview of what affects statistical significance and why statistical significance is important. Like I said, this entire lesson is just a warm-up lesson for our class. It's just meant to expose you to some ideas that we'll be building on later. So, like I said, when you do a significance test, you calculate a value that tells you if you have a statistically significant result. And that value is affected by three factors that we'll go over right now. There are three factors that contribute to statistical significance in a psychology experiment. The first one is the size of the difference between the means of the conditions. You're more likely to pass a significance test and get a significant result if the difference between the means is large. That's because a large difference isn't likely to appear just because of random chance. And I'll show you an example here just to help you understand what I mean. So here I just drew a few hypothetical outcomes, or some imaginary outcomes of the temperature experiment that I've been describing. And in each bar, I put the sample size. So this is meant to be 2 people right here, and 2 people right here, 2 people in the cold group and 2 people in the hot group. So let's take a look at this middle outcome right here. In this imaginary outcome, the 60-degree group has 30 people, and the 80-degree group has 30 people, and the mean of the first group is 7.5, and the mean of the second group is 7.4. The two groups performed about the same on the recall test. This difference in performance is probably not statistically significant. It probably wouldn't pass the significance test because it's so small. The cold group outperformed the hot group by only 0.1, and a difference this small could easily happen just because of chance factors. All it would take is maybe 1 or 2 extreme people in the cold group to bump up their average to 7.5. For example, if 1 or 2 people had an extra cup of coffee, that might be able to bump up their average to 7.5 and create this little difference in performance. So if this was the outcome of the experiment, you wouldn't be able to confidently say that the temperature of the room is what caused the first group to outperform the second group, because it could easily just be random chance. This probably would not be statistically significant. But if this third imaginary result was the outcome of the experiment, and the cold group had an average of 7.5, and the hot group had an average of 5.7, that difference probably would be statistically significant, because this big of a difference isn't likely to happen just because of chance factors. If the cold group got a few extreme people just by chance, that probably wouldn't bump up their average this high. It probably wouldn't bump up their average this far above the average of the hot group. So if this was the result, you could confidently say that this difference in performance was caused by temperature and not just chance factors. So like I said, this result probably would pass the significance test, and it probably would be a significant result. The second factor that affects statistical significance is the sample size. You're more likely to get a significant result if you have a large sample size. Because if you have a large sample size, your data is more reliable, basically. So let's imagine that this first graph is the outcome of the temperature experiment, and the cold group has 2 people, and the hot group has 2 people, and the cold group has an average of 7.5, and the hot group has an average of 5.7. Even though the cold group outperformed the hot group by quite a bit, this difference in performance probably wouldn't be statistically significant because the sample size is too small. You can't reliably compare 2 people with 2 other people. This difference in performance between the hot group and the cold group could easily just be because of random chance factors. Um, maybe the cold group got two alert people just by chance, and the hot group got two tired people just by chance. That could easily happen. So if this was the outcome, it probably wouldn't pass the significance test. It probably wouldn't be statistically significant, and you couldn't confidently say that the difference in performance is due to the temperature of the room. But if this third graph was the outcome, and there's 30 people in each group, and there's this pretty big difference in performance, then you probably would be confident enough to say that the difference was caused by temperature. You could probably confidently say that the temperature of the room is what caused the cold group to do better than the hot group. And it probably would be significant because the large sample size and the large difference in performance are both contributing to the statistical significance. The third factor that matters is the standard deviations of the conditions. You're more likely to get a significant result and confidently say that the results aren't due to chance factors when the standard deviations are small, and when you have consistent data in each condition. So if the people in group one are hugging their average pretty tightly, and the people in group two are also hugging their average pretty tightly, that makes you even more confident that the conditions had an effect and that the results aren't just due to chance factors. And if you think about it, I think that makes sense, right? If the cold group typically always does better and the hot group typically always does worse, that makes you highly confident that the temperature of the room had an effect. But if the cold group is all over the place and the hot group is all over the place, then you're less confident that the temperature is what caused the first group to do better. Because if the data is all over the place, you're going to be more suspicious that the results are just due to random chance factors. So these three things all contribute to statistical significance. So basically, each of these three things contributes points towards statistical significance. And if you earn enough points, you pass the test and you get a significant result. I want to share an analogy that I think might help. So if you're taking a class, your final grade will depend on more than one thing. Your final grade will depend on, let's say, exams, quizzes, and assignments. And each of those three things will feed into your final grade, and your final grade will either be pass or fail. In the same way, these three things all feed into the value that's calculated during a significance test, and then that value tells a researcher if the result is statistically significant. And if it is, the researcher can confidently say that the result is not due to chance factors, and instead, the results are due to the hypothesis.